Just wanted to share a waveform capture from a 6.8 liter natural gas Generac H panel unit. Hopefully I don't get torn apart. This is pretty brave posting a video here, but I know there's some guys that are interested in the data acquisition part of our job, and this was just kind of neat to see on a capture here. So this is a capture. We got red is crank position. I think it's a 36-1 reluctor wheel. Yellow is the cam, and then I'm probed into let me look at my paper here, cylinder 10. This is the no start, this is the pause, and this is the start. Every second attempt this thing will start. When it doesn't start, a lot of times we get a harsh backfire and the engine binds. Previous techs have done fuel work on it. It does present like fuel work. It's intermittent, always starts on the second try. At least that's when I came there today. Every second try you get the pause and then it would start. We've had problems with the crankshaft reluctor, the keyway either failing, and we'd have play in the reluctor wheel, and we'd get our mechanical timing wouldn't be in, but our ignition timing would drift. And we've also had them break where mechanical timing would fail, and you'd know right away because you wouldn't have any vacuum. But anyways, I digress. So I was expecting to see that today, and after doing just a regular old cam crank correlation, I think it's here. I did it a couple different ways. It all looked good. In other words, I think it's always like between the 6th and the 7th. And for people who aren't into scoping, I'm going to look at the waveform. So basically, this is our index. The yellow is the index for the cam. Here, between here and here is 360. So between two of these is our 720. And the cam is going to tell us, what side we want to fire on of this 360 or that 360. So we're not firing in top dead center of exhaust. We want to fire top dead center on compression. Side note, some of the automotive Ford ICMs, if you have a failed cam sensor, they'll revert to a waste spark and they'll fire in top dead center compression and exhaust. So anyways, I was lucky enough to get the capture with the unit failing as we had in the first one. And at first I had thought the system was just losing, it was firing on the wrong side. So I'll show you here. So it's pretty neat to see the no start, then the start. So we'll start with the no start. Yeah, we'll get the no start going here. And I think, let me look up, I know in here, I think it's, if you forget how many flywheel teeth we have, I have a little spot in here, flywheel. I made a little chart. 6.8 liter. Is it 168? Okay. So you have 168 tooth flywheel with a 36-1 reluctor. So I'll make the zoom window. We're probed into cylinder 10 here. And I apologize. I was using a different scope and I had it set for an amplitude of 20 plus or minus 20 volts. So we're capped off on our ignition signal. So anyways, it's very easy to see. We are firing cylinder 10 in the first, between the two indexes that does not have the cam pulse in it, right? So so we can definitely see here to here is 360, then here to here is 360. The 360 that has the cam does not have cylinder 10 firing in it. Very easy to see. So if we zoom out to full and we go over to the run signal, the engine pauses, and then we start and run. You will see cylinder 10 is now between the two indexes, this side of the 360. Obviously, since it's running, we are firing top dead center of compression, and we are firing, I think it is, how many degrees we can do this. So it's firing, well, the other one was firing over here, we're firing over here. Now, I had thought it was just losing input, like we had a cam sensor problem, and was just firing exactly 360 out. If that was the case, we'd be the same distance away from the reluctor index. So not until I got home, that's why I like saving waveforms. So if I zoom this in a little more, what's really nice, a lot of times I won't like have a channel. If you catch, you know, you can catch some interference, so we can see the other fires, the dwell, and then the release. So so if I take two cursors, I get some cursors here. This scope is pretty cool. H scope does it too. Actually does it just as good. And then I can mark cam 360. I can mark cylinders, but I'm going to mark. I'll mark the 360 because we are cursored at 360. So now we know where we are as far as crank angle space goes. So if I move this cursor over till that ignition event, we are 227 degrees after the crank index. So if it was just a case of the ICM misinterpreting the cam signal, we would be around 227. So if we go zoom out to full, and we go over back over to here, zoom window. What am I doing? Okay, so obviously we can see we got a very short dwell here. So again, we're not in the index that has the cam. Bam, bam, we don't have a cam pulse there. So if I mark my 360, so I get my cursors again because we're at a different speed, so we have a different time base in this section of the waveform. We mark 360, and this is a gearbox unit, so you'll see when it calculates the RPM, we're at 216 because we're cranking, and then I can pull this cursor over, and we're at 194. So we're not only 360, but another 30 degrees about. So it's not exactly 360. So now I've had problems with the Mopar or the Dodge ignition control modules, where I go back with one, plug it in, it works, mount it to the chassis, and it failed. I had a few brand new ones right out of the box do that. So I'm on site with no parts, and I figured, hey, maybe this is failing. So isolating the ICM resolved it. The unit started 20 times in a row. I screw it back into the plate without it being isolated. It would go back to backfiring on the first crank attempt, and then starting on the second. Every time it misfired, our cam and crank signals were the same. No mechanical movement. Again, I did a cam crank correlation. I even go to the dual scope, and I triggered on the cam high signal, zoomed in, and then I would watch for the any drift of the crank back and forth. You can see it float if you're triggering with the cam pulse in the center of the window, and the crank as any like a slacken your timing chains or whatever, you would see oscillation back and forth, and you could pin some cursors in there and see if you had any drift. Nothing of the sort. The mechanical timing has been solid all the way through. So just thought I'd show a kind of a neat way that an automotive, cursors on an automotive scope Again, I needed a third channel, so I used the ATS equipment, but I usually, H-scope has all that stuff too. And it's battery, it's an isolated scope, so for engine work, it's not bad. So hopefully someone got something out of that. Like I said, it's running right now. Kind of deciding what we're going to do, if we're going to go back with a new ICM, but I've had new ICMs fail by connecting them to chassis ground. So I don't know, kind of monitoring the unit going forward right now, and then kind of decide what we're going to do. All right, hope everyone got something out of it. Cheers.